I am going to make sure you can see my screen, which I'm not sure you can.
Looks
Can you see
looks
my
good.
screen?
Yep.
Yeah, great. Okay. All right. So welcome, everybody. So glad to have you here today to meet with Michael Olschimke. And I believe I'm saying that, Michael. Do you correctly?
It's good enough.
Good enough?
It's,
Okay.
yeah,
Okay.
absolutely. Mhm.
He's going to talk to us today about the evolving data ecosystems, about the power of data vault, data mesh, and AI. And just before we get into that, I want to spend a couple minutes to tell you a little bit about DAMA Northeast, if you don't know about it yet. Many of you are members of our community, but some are not. So I just wanted to give you a little overview of who we are and what we do. We've changed our name. Lovely. We like to call ourselves DAMA Northeast these days because we've expanded beyond the 4 original New England states. We offer education and professional networking to our community here, all the way down to Washington, D.C. now, up to Maine. We've got members. Some of you know and are on this call today. So we have webinars and on-site events, as well as offering our learning program for those that are trying to become certified in the data management professional certification through the use of the Data Management Book of Knowledge. This is what our membership includes. So for your discounted admissions, we're trying to build our membership base and have more community and member hosted events. If you're not a member or you know somebody who should be a member, feel free to scan that QR code, which you'll see several times during this early part of the call. There's also our link down below that gets you to our website. Some logistics quickly. We have a chat feature, obviously, in Zoom. You're all familiar with that now. What I'd ask as we start out here, when Michael hands over, or actually while I'm still speaking, if you type your name in, it could be first name, you don't have to put your full name if you don't want, but put your name in, where you're dialing in from, and then maybe what your role is or what you're interested in. And I'll be monitoring that while Michael starts his presentation. And if there's conversations and topics we want to add in and ask him, we'll make that work. Staying on mute, of course, unless you have a question, please use the icon to raise your hand, and I'll be looking out for that. If you can, turn your camera on. It's always more interactive and fun if we can see faces and reactions. And then we will be posting all of this content, of course, to our website in our members section when it is time. This is just a quick preview for those that are on the CDMP track. This is a list of our study groups. Our next event for studying Chapter 6, which is data storage and operations, is actually tonight at 7 p.m. East Coast time, US East Coast time. So that's just a small advert for that. And without any further ado, I present you Michael Olschimke, and he's going to say it the correct German way when he gets his turn to speak. Yeah. But I'll just use my American accent for now. Michael is a seasoned data scientist and entrepreneur, and he guides organizations through the evolution from data-driven to AI-powered. He's a consultant, he's an author, he's a speaker, and he likes to share his extensive knowledge on big data and AI by training and educating people like me and you. He co-founded Scale Free, and he'll talk a bit about that today, a leading data consultancy, and Flow.BI, which he'll mention as well, a new Gen AI platform for integrating enterprise data models. And basically, our event with him today is to just listen and learn about how all of these technologies that we've got, and we have our preferred ones, how they are not independent and work independently, but how do they actually work together to make us have the best infrastructures, the best models, the best architecture that we can using the right strategies at the right time. So I will pass it over to Michael. I'm going to stop sharing my screen, and Michael is going to share his.
Cool. Let me share my screen. I'm sitting in the car on my iPad, so I'm losing my webcam, but you saw me good enough, so let me just share my screen here. Should pop up. There you go. I believe you see my slide deck now. Okay, so my name is Michael Olschimke. That's the German pronunciation, which is good enough. Typically I'm just Mike. It's good enough.
Okay.
And apologies, I'm sitting in the car because I'm got kicked out of my customer for security purposes, and now I'm essentially the hotel is too loud. So I said, okay, let's go to the car, and because I'm leaving tonight for home. And Yes. So what I'm doing, I always feel like a junior if I'm all to be honest. I have more than 20 years of experience now, 25 years of experience in the data industry. I started as a software developer, and then really found my love. I mean, I was always working with data and data models, and found my love at my for BI and data analytics in my exchange term at the University of Oklahoma back then. And then when I got my scholarship for Santa Clara University, that's where I really focused on data and just data essentially. So we distribute neural networks on MVP clusters for classifying unstructured data sets. That was my research topic. And later I started out as a data vault practitioner, if you want. Did a lot of trainings all over Europe here on Data Vault 2.0. Co-founded with Dan Lindsay, the inventor of Data Vault, the Scalefree, which is a consulting firm in Europe. And then and we're serving customers all over Europe, from Norway all the way to at least Switzerland, Austria, Italy. Those are the directions, and all the way from west to east, essentially. And we're doing big data solutions based on Data Vault. Yeah, everything you can imagine, data platforms, real-time streams, semi-structured solutions, and so on. And I want to talk today about a topic essentially that combines Data Vault, the data mesh, and artificial intelligence. My topic, if I would have let's say a focus of my career or whatever, I would say that my goal is really to turn data-driven organizations into AI-driven businesses, where AI plays a much bigger role than just the consumer of data and then making decisions. What about having AI integrating data in data flows, essentially, right? So that's one of the topics, essentially. Okay, so let's talk about today's topic. So I want to talk about Data Vault, Data Mesh, and AI. I like your title. That was essentially changed by DAMA here, Evolving Data Ecosystems. So I start with, it influenced my agenda here. So I will start with how it all began, how we can learn from each other. I mean, especially how Data Vault and Data Mesh can learn from each other, some blueprints, and then how can we replicate success, and in the next last step, how to adopt for AI-powered data integration, essentially. So initially, when Data Vault was invented in the 90s, it was a concept for the development of enterprise data warehouse systems, of data platforms, essentially. Never intended to be central, but most customers, or many customers, are using it in a more central approach, essentially. But Data Vault itself, and I believe most people here in the class know it. If not, raise your hand, ask questions. I'll go for it, right? It's a concept that can integrate real-time feeds, batch-driven data feeds. It can integrate semi-structured data sets, unstructured data sets. We have cases where we used a Data Vault. I mean, the typical case is to use a Data Vault on a data platform. You absorb the data, restructure it, and derive a target model, star schemas, Kimball designs, and so on. And then we also have cases where we use Data Vault for integrating real-time feeds, where we don't persist the data. It's just in memory for a while until the data is integrated, or these message queues are integrated, and then you forward the results, essentially. So the Data Vault doesn't have to be persisted in that sense. And we have customers where they use Data Vault concepts to integrate documents. So they receive, let's say, JSON or XML documents, different ones, but describing similar items, let's say contracts. And you want to integrate these documents and then turn them into a new document, for example. Maybe you want to summarize all these documents and come up with a new document that's derived from all these inputs, and forward that to your consumers, essentially, to your information consumers. Those are cases. Not the typical case, but those cases are supported, essentially. And Data Vault really has a focus on automation. Data Vault is based on patterns, lots of patterns, how we model, how we set up the architecture, and you will see this today, how we run the project. And especially for implementation and for the model, we can automate the generation of these patterns, essentially. We can, today's projects are typically not, we don't build the Data Vault manually these days, or model it manually these days. We use automation tools, and they will generate you the create table statements and the insert statements for the whole Data Vault design, for the whole Data Vault model, the model itself, but also the loading patterns from the source into the raw Data Vault essentially. And also for the later layers, there are concepts, and customers are using these concepts to some extent, how to generate the business vault, for example, how to derive the information marks using metadata, and so on. So you can automate a lot with Data Vault, essentially. And Data Vault's basic idea is, for those who don't know it, that there's essentially 3 fundamental components inside your data, any data. Doesn't matter if it's your enterprise data or your personal data, let's say on LinkedIn or Meetup, for example. You always have business keys involved. Business keys identify the business objects. For example, you on LinkedIn or your social media platform of your choice, you have a username. This username identifies you as a social media user, essentially. Then we have relationships to other business objects. There's a social graph, so you know other people. That's a relationship between 2 business keys, your business key and the business key of the other person. But then there's other business objects like advertisements. They have an advertisement ID. There's user groups where they have a group name, for example, as an identifier. And when you join one of these groups, you establish a relationship between your business key that identifies you as a profile and the user group, for example. Or when they present you an advertisement, you have the you have an advertisement ID in relationship to your profile because they showed you this advertisement. And then we have the third element, that's the descriptive data. That's essentially where you have descriptions behind username, or sorry, behind business keys and behind relationships. So there is somebody behind your username, and this somebody is you with a first name, with a last name, a birth date, and so on. Those descriptive descriptions. Same is true for advertisements, where you have maybe an advertisement title, maybe some other like the text, the image, and so on, or the groups with the group names, the group descriptions, and so on. And then you also have descriptive data not only on the business keys, but also on the relationships. So since when do you know another person? When did you join a group? When did they show you an advertisement? Did you click the advertisement, and so on? So there's different descriptions either on the business key or on the relationship between business keys. And those 3 fundamental components you have in your data. Your enterprise data consists of these 3 fundamental components and your personal data. And it doesn't matter if you use Data Vault or not. Those components are inside your data. And Data Vault is really designed around these components. So we capture, for example, business keys in hubs. That's a distinct list of all the business keys used in your enterprise to identify social media profiles or products, customers, stores, and so on, across all your source systems. So the hub contains all the business keys that identify stores or customers in all your source systems. Then we have relationships. Those are stored in links. And descriptive data is stored in satellites. And satellites, the purpose of a satellite is to keep track of changes, because when your customer relocates, they get a new address. When they marry, they get a new last name. When they when the list price of a product gets changed, you get a new delta. And a satellite keeps track of these changes. So whenever there's a change on your descriptive data, the satellite captures this change as a new delta. And that's where really the data warehousing happens, essentially, in a clear sense. So that's the basic idea of Data Vault, of the model. We come back to this pattern because we see a pattern here already, right? We have 3 basic patterns, and we'll come back to that later today. That's the model, without going too much into detail, because today is really more about architectures and topologies. So when we look at the data mesh, we have 4 core principles. One is the domain-oriented decentralized data ownership. So instead of us in the centralized data platform building all the reports, all the solutions, we export or push some of these responsibilities over to the domains, to the business units, or what you define as domain, and leave it for the domains to build those solutions. To what degree, what they will building, or what they are essentially, how much responsibility they get, depends on the architecture. We talk about that. Then we treat data not just as data or information, and that's what we deliver here all the time, but we treat data as a product. So there's a product principle here where we are pretty much focused on the information consumers who are going to use our assets, if you want. What are the requirements? What are they happy with? What are the features they want? And then also to market our product, to make sure that they understand the value of it. There might be a catalog involved, maybe an online shop where they can buy access to these products, maybe a user account, or maybe the delivery of the solution into my target database platform, for example, or into my data lake. So they can order the deployment into my system and into their system. And but I have to market my solution now. I have to market the idea of my product, what's the purpose, what's being used, and so on. And there's actually internal competition inside organizations when they go for a data mesh. If you building a product and you want to, in quotes, sell it on your catalog, or on your online shop if you want, they have options. They don't have to go for your products. They could also build them by themselves, hire a consulting firm, build them, and so on. And the idea is that this raises the quality of these data services that we offer them. On the other hand, we have a federated computational governance. So the idea is that these data products should interoperate with each other to the point that you could use the output of one data product as an input for a next data product, for example. So you talk about data contracts to make sure that the interface works together, right? People need to know the quality of these data products and so on. And then it's really about self-service. So we as a data platform, we would essentially provide them a platform, maybe raw data, and then the idea is that they can build their own solutions essentially, given the assets that you give them essentially. So that's the basic idea. So the question becomes often: is there a competition between data vault and data mesh? Is it do we have to decide on one way or the other? And no, in fact, both options address some common data challenges. For example, what we see is that traditional data warehouse solutions, they often struggle with increasing data volume, with the typical big data Vs, with variety, volume, velocity. They can't deal with the volume of data, the complexity, and so on. Or they struggle with the agility and the automation, that the patterns inside your current data warehouse are not that clear, let's say. So you don't have those clear patterns, and you can't therefore have a hard time to automate these patterns, let's say. There's always patterns, but depending on the design, you might have a variety of patterns, etc. Or it takes a long time to build anything. We have customers where it took them years to build a new report or something because of all kinds of dependencies and so on. And Datavolt addresses these challenges essentially. So typically when we start a project, we have a few setup sprints, but then it's really we're delivering some business value sprint by sprint, starting with sprint 1 essentially. If you count sprint -1 and 0, that's a prepare sprints, and then sprint 1 should deliver some business value, and that's what we get done. And then every 2 weeks, every 3 weeks, every 4 weeks, whatever you define as sprint duration, we can deliver new functionality sprint by sprint. That's the basic idea, and we get this done actually. All right, so they don't compete actually. In reality, they are more or less they complement each other. There are certain aspects of both data mesh and data vault that are more or less where they address the same, but there's also aspects where they address different aspects of the data product or of the data warehouse, and those are actually complementing. So for example, both data vault and data mesh, they are based on distributed architectures. Yes, data vault is often used as a more centralized data warehouse or data platform, but in reality, it's not limited to that. So actually the original design was for distributed enterprise data platforms, where parts of the solution might be on-premise, parts of the solution might be on different platforms, essentially in different geolocations, for example, or different organizations, and you could combine those individual parts of your solution, those distributed parts of your solution, in your queries. So I could query, let's say, some data from my northeastern data center, and then I'm joining data from the cloud, for example, and that gives me my input for my dashboard, for example. So it's very much based on distributed architectures, both of them, and then both deal with standardization on different levels. In all honesty, we'll talk about that. So Data Vault is more focusing on the standardization of the implementation of your data product and the modeling, while the data mesh is more on the standardization on the architecture side, for example. But it's complementing each other. It's not in competition to each other, right? And both are dealing with self-service, where your business users, your power users at least, they should be able to build their own solutions. In Data Vault, we call this managed self-service BI because we allow self-service BI on a managed platform where we deal with security, privacy, deleting personal data, for example, which is a big deal in Europe, GDPR, right? So the right to be forgotten, that's a big deal, and that's all supported by Data Vault essentially, and that makes it managed and other aspects. And so those are the similarities. The differences are quite simple. Data Vault is really focusing on or mostly focusing on modeling and implementation. Yes, there are also architecture designs and methodology, for example, but they're looking at different aspects on the layers, for example, how we implement a data platform layer by layer, and less on the distribution style essentially. And then also automation, because data was again based pretty much on patterns, and it means we can, and especially on repeatable patterns, we can automate. That's the basic idea. So it's a lot of implementation and modeling, especially for today's focus. And then data mesh is really more on the organizational side, on the organizational aspects, on data ownership, on the distribution of your architectures, and so on. So there's no competition here. It's actually very much complementing each other. So and we have more and more customers. I'm just jumping out of a customer today, where we discussed essentially to turn this organization more into a data vault, data mesh organization, and we have more and more customers where they're using this essentially as a combined approach. So Data Vault, yes, is often used as a central data platform. I said this already, but it was initially designed for distributed and decentralized data platforms, and essentially where you have a requirement for data separation on a need-to-know basis, and that's where it was designed, essentially, Data Vault. And that, with that in mind, it's actually a good fit for data mesh, where you want to distribute your architecture, your data solutions into different domains. That's where the Data Vault design here comes into play very much. Standardization, as I said, both rely on standardization. Why? It's quite simple, because if you want to decentralize, you have to standardize, because without standardization, decentralization turns into chaos. So you have to standardize if you want to decentralize, and that's what both sides realize, both data mesh and the Data Vault realize essentially. And again, standardization is essentially the foundation for, or repeatable patterns are the standardization for the foundation for standardization essentially. Again, comes in handy here, that both concepts rely on patterns essentially. Yeah, and in Data Vault we call this managed service BI, as I said. That's really where you have data citizen, power users, data scientists building their own solutions in what we call a user space. So even on a centralized platform, we provide the standard architecture, which I'll show in a second. And on this architecture where we define certain layers, we provide a user space. And in this user space, you can do whatever you want. It's a green field. Do whatever you want, but from a managed perspective, we have to put up some fences. So there will be some fences around your green field, essentially. Those might exist for security reasons or privacy reasons, auditing reasons, and so on. There's certain organizational requirements or legal requirements. For those reasons, we have to put up those fences. But other than that, it's a green field. As long as you say inside the fence, do whatever you want. And that gives you a lot of power to build your own custom solutions. And the idea is actually, and this is what I tell all the customers that we have, all our clients, make sure those fences are not too narrow, that your users can have a wide solution space, what kind of solutions they can build, because if it's too narrow and they can't build a solution anymore, they going for alternatives. And the alternative is a spreadsheet, and that's what you want to avoid, essentially. So we allow them actually a lot on the platform, but we also monitor it, for example. We make sure that the data in a data platform is secured, row level secured, column level secured, that the data is, that we remove personal attributes if we have to remove them for legal reasons or regulatory reasons, that we remove the attributes. So as a power user, when you consume the data, but also the business logic from the data platform, you can rest assured it's already clean. So it's all managed. Just use the data. Again, with some, I would recommend do it virtually using views, because then whenever we remove some attributes or some personal data, you don't have to deal with anything. It's all done. So the platform is managing the data processing essentially, and that makes it very powerful for many clients essentially. And yeah, so what I want to talk about today is really blueprints, because in data mesh, let me just double check this. Yeah, think about this in data mesh. When you build a car in an automotive factory, the car looks from the outside all the same. So they look all on the picture. You got your nice and shiny car. But the problem is when you open up the engine compartment, the engine is completely different from car to car because you left it to the engineer to decide on how to build the engine. And it leads to the fact that every engine is different. And in the worst case, and I've seen these worst cases many times, there's no documentation on the engine. So yeah, it's not documented and the engineer has left the company. That can't be an enterprise approach for building data products. But that's a often seen approach for data products where you define essentially how the data contract looks like, how the interface looks like for your data product, how it looks like from the outside, but from the inside, everybody was doing whatever they wanted, essentially. That is not a enterprise approach, essentially. So what we need is a blueprint for how we build the data product, the engine, essentially, under the hood, right? And this blueprint could be anything. You can come up with your own pattern, but could also be data vault, because data vault is really about implementing and modeling the data flows inside your data product. That's the basic idea. Think about this. When you build your data product, and this guy here brings in data vault, but it could be anything. But when you build your data product, you have some source data. The source data is essentially the data coming from the source systems or from a previous data product. And but the problem is this source data or this input for your data product is not defined by you. It's defined by the originating source. Maybe a source model, maybe the interface from the previous data product that defines your the structure of your source incoming source data. And so that's one thing. And then you, with all the quality issues and missing data and so on, right? And then you have an expected output. So you define, or maybe your consumers define, what kind of structure they want to have from your data product. They define, let's say, maybe for analytical purposes, they would like to have a star schema with facts and dimensions. Maybe they define a 3NF model. Maybe they define a real-time feed coming out of your data product, essentially. But this target model is defined or driven by the information requirement by your end users. And it's independent from your incoming source data model. And the content is also defined. So they don't want to see bad data in most cases. They want to have the missing gaps filled. They might want to have everything in US dollars, for example, and they don't want to see euro values because your leading currency is maybe on your report in northeastern US is US dollars. So everything should be in US dollars. So they define the structure and the content, but your source data is not matching it. So there's a gap. There's a gap in between the source data you receive and the information model you should deliver. And this gap you have to bridge. And that's where data vault comes into play, because as long as you can provide me with the fundamental components, the business keys, the relationships, and the descriptive data, I can derive any target model from it. Because there's patterns for this, how we derive dimensions and facts from your source data, from these fundamental components, essentially. And also when you have to cleanse data or when you have to transform data, turn all the foreign currencies into a leading currency and so on, or into any currency at the same time. We have patterns for this, and these patterns are based on the fundamental components again, but these patterns exist and we use them all the time, essentially. So it might, if you want to consider data vault, it might make it much easier for you to bridge the gap. That's what my proposal is. The architecture in data vault really follows a pattern, and that's the Maslow pyramid. And Maslow, he came up with two pyramids. One, which you might know from school, is on needs. When you have the basic needs for food and drinking and so on is done, then you want your Ferrari and so on, right? So you fulfill your needs essentially step by step. And the other pyramid, which is not that much known from him, is the DIKW pyramid, where we have data on a very basic level. I hope you see my mouse. We have data on a very basic level, and those are the facts coming from the source systems. Then we turn those into information. Information that can be used by end users to make decisions and so on. And they typically we read the information from reports or dashboards. And when we read them, we consume essentially the information, and it becomes knowledge. We apply information in our head, essentially in our brain. And then when we internalize this knowledge, it becomes wisdom. And I always give an example. Let's say, so I'm originally from northern Germany, Hanover, Hamburg, essentially. And in let's say we are producing wheat sausages and wheat beer, and all in a sudden, what we see in a report, I mean, the ERP system delivers us the raw data. That's the source data. We turn into an information model, maybe a star schema, and we present it on a report on a dashboard, or a report or dashboard something. And as a business analyst, I realized now that around September, the consumption goes up in Bavaria on wheat beer and white sausages. And you wonder why? Well, you could combine different information sources, let's say different dashboards, maybe also other external data information sources like newspapers, and realize there's an Oktoberfest going on. From northern Germany, I have no idea why the Oktoberfest starts in September, but it's what it is. So be it. So it starts in September, and then the demand picks up. And guess what? It's every year. So while we apply the information, turn it into knowledge, now we learn something, essentially, something very important. We learned this, but honestly, it's every year, or most years. It wasn't there for COVID, but other than that, it's every year, which means that you don't have to read the report. You know the demand for those products will go up every year in September. And so, increase your stock essentially, because you're going to sell this. And we don't need to read the report. We have internalized the knowledge and became wisdom essentially. And this pyramid here is what we're implementing, what you implement when you build data products. But we are focusing on, as IT specialists, we are focusing on those two layers, because those two layers, the wisdom and the knowledge, must be done by humans, by you with your brain essentially. But the data and information layers, that's what we're building in the IT systems. And that's what you see in the architecture here as well, in the Data Vault 2.0 or Data Vault reference architecture. What we see is the blue layers here, they deal with raw data, with the data. So we have the data lake or staging area sometimes. We typically use a data lake as a massive, persistent staging area, essentially. Consumes or absorbs the data from the data deliveries from the data sources. And then we feed that data into the raw data vault, where we break your incoming source data sets into the fundamental components and store it in HubSync satellites. So here's where we have the data vault design. And then the white part here, those start to deal with information. The information model is on the information marts. That's your target model. It's a star schema with the right content, the right structure, everything's perfect. That's what the users want. And the business vault is used to bridge the gap. It's still in data vault design, but it deals really with the content, where we convert your foreign currencies into leading currency and so on. That's the basic idea. So what we see here, those two fundamental layers, the data layer and the information layer. That's the basic idea. It's blue and white because blue is materialized and white is what we typically visualize. That's another story. Okay, and then we have the dashboards where we essentially present the information essentially later on. And that's the pattern for the architecture. That's our pattern here. And that's the pattern for today, more or less. There's one more pattern for the methodology. When we go agile, when we go in and deliver the data products and iterations, we typically have also a pattern how we deliver these data products. What we realize is, when we follow this architecture, when we follow the modeling style, that every sprint, every iteration is more or less the same. You have to attach some data sources to the data lake. You have to creatively break down the incoming data sources into the fundamental components, model it as HubSync satellites, attach the business rules, derive the information model from it, build the dashboard, you're done. That pattern we have all the time, sprint by sprint. That's the basic idea. And this pattern we then codify, if you want, in sprint plans. And those sprint plans we can optimize. That's more going into the continuous improvement of your development processes. CMMI, that's a longer story. I keep it out for today. But it's just another pattern that we see in the data vault architecture. And there's other patterns, like how we apply business logic in the business in the architecture on your model, how we derive, let's say, currencies, clean up currencies, and so on. But also how we derive information and dimensions and fact entities in the information marts that also follows patterns. There's only a few patterns how we build dimensions. Depends on type 2, type 1, for example. That's the basic idea. Those are also patterns, right? So yeah, business vault we typically visualize. So most of the entities in the business vault are just SQL views. We can also use external scripts. We follow insert-only approaches, incremental approaches. So we don't want to touch data multiple times. I mean, why should you calculate the same business rule on the same data you did last time? That's an issue because if you have increasing volumes of data, you will end up in a scalability issue. So we only touch or apply business rules to those new data records where we haven't applied the business rule in the last by the last time. And insert only, we want to avoid any updates, because updates means we're losing old versions of your record. So we only do inserts. And the only deletes I'm doing is because a lawyer tells me for GDPR reasons or HIPAA reasons or whatever, you have to delete this data, and not going to argue with your lawyers. That's what it is. So then I'm deleting data, but that's the only reason. So organizational or legal reasons to delete data. And we can also deal with changing business rules, changing data structures on the raw data side, but also changing business rules when they change over time. Easy to implement based on those patterns, essentially. Not going into detail because it would break you wouldn't have any time for questions anymore. And as I said, for dimension facts, we also have patterns. There's only a few patterns how we derive dimensions from HubSync satellites and facts from HubSync satellites, based on type 1, type 2, and so on. All right, so those are patterns that establishes patterns. Now let's replicate the success. And the idea now is that when we look at the data mesh, there's different topologies, essentially distributed architectures, how we can organize the system. And this one here is the first extreme, where you leave it to the domains, you leave everything to the domains. So you have no centralized platform, everything is run by the domains. And they could use this architecture pattern we saw with the data lake, the raw data vault, the business vault, the information mart. They could use this as a pattern, how they organize the internal structure of the data product. Because it's not just the engine, there's more than just the engine, right? I'm sitting here in the car, I see well, it's an EV, but we have an engine typically somehow, and then we have seats, we have a luggage room, and so on, right? So there's different places, different artifacts that we need to build. And this is my architecture here, essentially. And all the cars look more or less the same. All the data products follow the same design, structural-wise. And then the data vault model would come into play on the raw data vault, on the business vault. That gives me more detailed patterns for the internal layers, essentially, of your data product. But this architecture, because it can be used for very big centralized systems, but also for very, very small distributed systems, even on a chip, on a microchip or something, you could build a data vault. Never done so though. But yeah, it follows the general design of the data vault architecture, essentially. And here we see that a product can use the input or the output of another product as an input for the next system. You could call this input output. I left on purpose, I left the data vault terminologies here a bit, like sources or staging, and the information mart, or what we call interface mart sometimes. I left this on purpose, but you could also call this input output or data contract. That's the outgoing data contract of the previous product, becomes the input for the next product, essentially. Yeah, one way or the other. And then you have applications that consume the outcomes of these data products. All right. Then what we see is a design where we have a centralized platform, where either data sources become the input for a data platform, or in this case, other data products. So you attach essentially data products to your platform, either as inputs to your data platform or as consumers of your data platform. And here's where you organize the data flows, because you saw on the previous slide, so for jumping back, here the connections are going wild, right? So they're going back and forth essentially. And here you centralize the connections more or less over your centralized platform to make it a bit more in a more organized fashion, essentially, or more governed fashion. And then the applications here, they could also consume the data from here, right? So that's also an option. And then that's an option where we have what we call the hybrid federated mesh, where we have a centralized platform. And here, this central platform is consuming the data from the applications, providing a more centralized data lake, raw data vault, business vault. And then the domain teams, they would focus on the information marts, on the target structures, on the dimensions and facts, maybe on the tree and F designs, third normal form designs, and so on. But the raw data itself, those would be essentially stored on the centralized platform. And the teams are just building information marts. And you can have business logic not only in the business vault, but by design in Data Vault, also directly in your dimensions and facts, and that would what the domains would do. So they would just add the business logic, the custom business logic they need to their dimensions, facts, or any other information models directly, essentially. And that design here we use with a couple of clients very successfully, because in the end, it's the most efficient design. You only capture the same data once. You don't have to store the same data multiple times as in the previous designs. And especially if the information marts are on the same database technology, those are just virtualized entities, just as in the standard data vault design, but under the control of your domains. They're building those information marts essentially. So this is the most efficient design, but the distribution also serves purposes, either data separation requirements, or when you have different data owners and so on, right? So different requirements for these other designs are there as well. We have a bank in Norway where they do this at the moment. So they built a data platform which is centralized. They use this for the data vault design, where they store I believe in this design, they have the raw data vault for sure, the data lake for sure. And the business rules, I believe, are all like the business vault is also on the domain. So they're building the business vault as well with the business rules and the information marts essentially. But they have a centralized data platform for efficiency reasons. That's what I've done essentially. And with that in mind, they follow the last slide, essentially the hybrid federated mesh topology. And they really focus on reusable data assets, data artifacts, like hub-sync satellites, your raw data, and the business rules. Data was really about reusing those patterns and reusing those artifacts you built, essentially. But the data products, the information marts, those are domain-oriented, essentially. And this is a proposal from this project, I believe. This was the initial proposal, at least, where the business vault and the information delivery is all done by the domains. So they are building those business vault entities. If you know our book that we wrote a couple of years ago, Building a Scalable Data Warehouse with Data Vault 2.0, we used to have only one business vault, but in most of our projects these days, we have one business vault per domain or per subject area, if you want, per function, essentially, of your organization, marketing, sales, and so on. And this follows this general design as well. So they can build the business rules inside their business vault, and then build the information marts consuming those business rules essentially. But even those business rules are reusable, so even other units can also use your business rules if they need to essentially. So that's how we built this in a more centralized fashion. But again, you could also decentralize this in the same way as we saw in the previous topology essentially. But most customers follow this design essentially, if they can. All right, last topic. The thing is this: we see these repeatable patterns, and the idea now is that we can derive, or we can recognize these patterns as in pattern recognition and build a good number of these layers fully automatically. And that's a topic of mine. So I founded two companies actually. I founded Scalefree, which is a big data consulting firm in Europe. We have a few US customers, but we're mostly operating in Europe. And then I founded another company called Flow.BI. That's essentially a Gen AI for integrating enterprise data models. So when you have different data sets, different source systems, let's say an ERP system, a CRM system, some online stores, and so on, your users would like to have an information model where they see all the leads, all the products from all these different systems. They want to have a uniform view. And for that reason, we have to integrate these data sets. And we do this all manually. But when you identify all these patterns inside your data, I started thinking of how can we automate the identification of these patterns. And that's what essentially Flow.BI is. It's integrating or building or deriving an integrated enterprise data models based on your attached data sets fully automatically. The whole raw data vault and the data lake, the first two layers we saw, those are AI generated. And then we focus on the business vault for the business logic and the information marts and the dashboard, and we're done. That's the basic idea. So it's used for deriving raw data vault designs, but it's actually not limited to data vault. It could also derive other designs like TrinF designs and so on. So there's an expert system involved that turns that or generates that. Yeah, so it's really about pattern recognition, identifying those patterns I'm talking about today inside your data sets. You connect it via JVC, it looks at your data, identifies these patterns, and then generates the first two layers here. I mean, the data lake is easy, that's source defined. But then the integrated enterprise model, the raw data vault, that's coming up with the business keys with the hubs, with the business key definition, the links, the satellite splits by privacy, by rate of change, and security and so on. And then we as humans, we focus on the business vault, implementing the business rules and the information mart entities essentially. That's the basic idea of Flow.BI. Check it out on the website essentially. Okay. Yeah, and it's yeah, as I said, it's a Gen AI. It builds all the hub sync satellites with the business keys, the special entity types. For those who know Data Vault, it's a bit more complicated. It's not just hub sync satellites. It also includes effectivity satellites or special patterns, let's say. Effectivity satellites, non-historized links, reference data, and so on. That's all included essentially. And not just the model. We have the metadata for the model itself for your hub sync satellites. For the create table statements later, but also for the loading patterns that will turn into your insert statements in SQL. We provide the metadata, and then we integrate with automation tools from the space. For those who know maybe Data Builder and Data for DBT, which is a DBT package to build Data design. That's on the GitHub of Scalefree of our company. And but we're also talking to other vendors to integrate our solution with these established tools essentially, but they're too early to communicate. That's the solution essentially, very simple, because AI does the work, so we influence the system, and yeah, that's the basic idea. And it really scales, so it doesn't matter if you have 5 source tables or 5,000 source tables. That's not a big deal because everything is built on MVP clusters and scalable essentially on compute clusters. Cool. With that, I'm done. I have some more time, so we don't have to stick for the hour. I have more time than 1 hour, right? So let me just stop my sharing here. Do you have any questions?
Thanks, Mike. Anybody have some questions for Mike's presentation here? It'd be great to hear from a few of you if you've got some. No bad questions. Just if you're interested, and maybe Mike, you want to share with them. Yeah, Harshal, please.
Yeah, so from AI perspective, I was thinking, how does this traditional DIKW pyramid model fits into the new requirements for AI? For example, ontologies, labeling of data, or from data science perspective, right? They are many data science professionals. They are also interested in many forms of the raw data and then connecting back to different labels. So how does this pyramid maps into this newer requirements of data engagement?
So maybe in AI, you know, the DMI AIC DMIC structure, right? This agile approach for AI or data mining. And as a data scientist, I'm always interested in both. I like to see the raw data, but I also am interested in the information, the pre-processed data from the data warehouse. I like to see both. So, and in many cases, I need both, but I don't know initially what I need, because when I'm building my model, I have a general idea what kind of attributes I need from the source and from the data warehouse, but I'm building my model. So it takes some iterations to improve the model until it meets the requirements until it meets the requirements. And for that reason, the data vault design, because it's so agile, we can easily add additional attributes or additional source data sets to the data platform, add them to this data vault model, and data vault really follows a graph design. And we saw this on the screen with this galaxy essentially. It's a scale-free network that we know from nature, like how your brain works essentially, or how viruses spread and so on. Those all follow scale-free networks, and the data vault design is really a graph network of your enterprise data, and we can expand this model step by step, iteration by iteration, adding more and more. And then in the next step, when we define a feature store or feature set, those are the attributes that we derive from your data essentially. And this feature store is from a data perspective just an information mart. It's the delivery of the attributes document-wise that you're requesting essentially. So we can extend your feature store iteration by iteration by adding step by step, more and more data to the raw data vault, maybe transforming it into attributes that you can consume, and then adding them to the feature store. And that's iteration by iteration, essentially extending your design. So we follow the same design here. We have inputs, your data, your raw data. We have the information, in this case, what the AI wants to consume. That's essentially the goal what we're producing here. But there's a gap, because you expect a feature store, but the data coming in is different. It's anything, right? So the gap we bridge again with Data Vault, with Business Vault, and so on. That's the basic idea. So we use it actually very successful on AI projects in very agile approaches, essentially. Yeah. I hope that answers your question.
Yep, sure. Okay.
Cool.
Thanks. Yep. And another question, it's more from semantic layer perspective. I mean, I haven't really used the semantic layers, but I've been getting calls from many product companies, vendors that have developed the semantic layer type of product. And have people really used those, or is it just more of a marketing buzzwords?
Yep.
I mean, I work for larger corporation, and
Yep.
I haven't seen the adoption of semantic layer in
Yep.
none of their business divisions.
Yep. I've seen it too many times, to be honest. And I'm not a big fan of a fully logical model. What I've seen is that sometimes customers, let's say you're a bank and there's different industry models out there for banks, and they try to fit the data coming from the sources into this logical model, essentially, only to realize that when they build the reports, that's maybe works fine in the first iteration, but then they want to build more reports step by step, iteration by iteration. And then they realize they need more data. They have to fit it into this model, and then they might have to adjust this model. And when they adjust the model, well, you have dependencies, you have reports attached to this. So you have to test your dependencies, and that this testing effort becomes bigger and bigger. So your agility step by step goes less and less, essentially. So what we do is here, what we teach and preach is a data-driven design, where we really focus, especially at the beginning for the raw data vault. The raw data vault is modeling your raw data as it is being used by the business, and that's a reference to your business keys only. So we integrate your data by the business keys, but other than that, we model your raw data. It's really driven by the source system. But think about this: when you model your enterprise, the enterprise contains two aspects here. One is the data that you have in your source systems. That's what it is. I mean, that's a fact. You can't imagine anything else. You got the data. That's what you have. That's the data-driven part. And then we have the business perspective. How do you think your business operates? You have customers purchase products, and so on. And that's what we can set up in the business vault. But in the end, in all honesty, it's all about information delivery. We want to, in the end, deliver reports and dashboards, KPIs. That's what we want to deliver here. And if that's your goal, we focus on in the enterprise model, we try to minimize the effort here. And so I always say in training, when seasoned data warehouse professionals hear the term enterprise data warehouse or data warehouse, many of them think about models. And maybe for DAMA, it might be right. But my thinking is a bit different. When I hear the term data platform, data warehouse or something, my first thing is about data flows. Actually about rivers, like rivers with water, right? They flow all the way downstream. You can split them if they're too large. You can join them, you can change the colors and so on. And the same is true for data flows. They originate from a data source, and they flow all the way downstream into your target. And you can split these data flows, you can join. We even use the same terminologies as with rivers. So it's really about data flows in the end. It's where also the term Flow.BI comes from. It's here about data flow organization. That's how we use the model, essentially. That's the basic idea. Other than that, I forgot the question. Yeah, semantic layer. So we use the semantic layer or the conceptual model. So we have that actually, but more on a very high level. So if for example, if I'm in your project, if I'm new to your project, I need to know what your business model is. So my question would be, what's your business model? What are the business objects, the concepts involved in your business model? How do you make money, essentially? And then you start talking about customers and products and so on. And I draw them up. I create a circle on a whiteboard, maybe. I add them, or in my Visio, whatever. I add some circles, and I have customers, I have products, and so on. And yes, I do add the relationships. But honestly, I don't care that much. I care more about the business objects, less than the relationships. And then once I have the business object of yours, the concept, then I would ask you essentially, so you talked about customers in the previous session or in the first half of the session. How do you identify customers in your source systems? And I make sure I have people from different organizations, different departments inside the meeting room. And then you start talking about, in SAP, we're using this SAP number. In Salesforce, we're using the account number and so on. You give me different business keys, and then I'm adding them to the business object. And that's my business key candidates, essentially. And when I'm integrating data sets into my data vault design, I'm data driven. So I'm looking at your source data set, and it's typically relatively easy to identify what's inside your source tables. Is it customers, leads, contacts, products, and so on? That's relatively easily for us humans. But then I'm looking at all these attributes. And for example, in Salesforce, on our account table, we have hundreds of attributes on the accounts. So what is the business key we want to use for integrating data? And we're looking for a business key which can be used, which is a shared key, because shared keys can be used for integration purposes. So in the ideal world, I would look into all your source systems and identify the best business key, which is known by as many source systems as possible. But nobody's going to pay me for this because it takes too much time. And what we're doing in sales, we asked you, and some of you said, well, customer number or account number and SAP number and so on. So I'm looking into my attributes. What do I have? Do I have the SAP number inside my data set? Do I have the account number from Salesforce and so on? And then those business keys must meet some requirements. Longer story, they must be unique, for example, uniquely identifying one row only, at least for standard data. And if they meet the requirements, I have my business key. If not, then I would come back to you and ask you, hey, I can't find your keys. What about those options? And those how we use these conceptual models essentially when modeling in a data-driven fashion, essentially.
Yep. Thank you.
Cool. Very high level.
Yep.
David. Thanks.
Yeah, so I think it's fair to say that the data vault is a model as opposed to a database. Now, when you're creating a database, what are some of the good tools in particular? We had a presentation in Boston in the past year talking about why Coalesce was really good for working with data vault.
Yep. So you need a database apparently. At least a database technology. You're not limited to relational databases. You can also use let's say a relational concept like Hive, for example. Very much conceptual. You can also use data vault for integrating documents. Because when you think about this, we're integrating based on the business key. If you have two JSON documents, maybe on a MongoDB database or collection store, these JSON documents describe something because they're documents. And what they describe, they also typically identify. So let's say they're describing products. Well, there should be a product number somewhere in the JSON. The location might be varying. So even from document to document, the location might be different. We have patterns how we deal with this. But these business keys are inside these JSON documents. Why? Because it doesn't matter how you store your data, your personal data or your enterprise data. It doesn't matter if it's JSON or XML or relational or whatever. These are fundamental components. It's inside all of your data. That's the point. So we can use those keys for integrating these documents or documents with relations and so on. Doesn't matter. So you need some technology how you store this data, and this could be a relational database, could be a relational concept, could be a MongoDB style JSON collection, and so on. Could be files on a data lake. And then because data vault is based on patterns, there are tools where we exploit these patterns. And for example, Coalesce is one tool where we partner with at Scalefree. And we built patterns for Coalesce, how a hub link satellite should look like on Coalesce, for example, or with Coalesce for Snowflake or for Synapse and so on. And those you find on our GitHub. When you search for GitHub Scalefree, you'll find our GitHub page with all our open source projects and the patterns for example, DBT and for Coalesce, they are on our GitHub. We also have other tools. As I said, DBT is a popular tool. Then we have tools like Warescape, for example, and Data Vault Builder that we partner with, VaultSpeed. And we have a few more patterns. For example, we have internally already the Warescape patterns. We haven't published them yet, but if you want them, we can send them to you. Those patterns we have. And yeah, so we partner together with Coalesce, DBT, VaultSpeed, Data Vault Builder, Warescape, There's a few tools, new upcomers like Iris Data from Australia, D Sharp is a new tool, which aligns very well with the design of Flow.BI actually. In Flow.BI we also have the conceptual model, for example. But the thing is that Flow.BI identifies the concepts into your data automatically, and then derives the rest of the data vault design by identifying those shared business keys and so on. But those tools are that we work with essentially. So there's actually plenty of tools to automate the data vault design.
Thank you, Mike. That's great. Thank you so much. We are at time. I have put this thing up here for DAMA Northeast. If you're not a member, please join. Mike, do you want to give a little hint on how people might want to best contact you, or something about your book if they have follow-up questions?
Yes, just send me an email. Check out our website, scalefree.com. That's our consulting firm, and Flow.BI is the other endeavor I'm working on. Those are the two websites, scalefree.com, that just send us a contact essentially if you want. And check out our GitHub with the patterns for how data looks like in Coalesce and DBT, for example.
Are you okay if they try to link up with you on LinkedIn?
Absolutely. Yep.
Okay.
Yep. Perfect.
Great. Well, Mike, thank you so much. Thanks everyone for joining. We have lost some of our groups, so I am going to let everybody go on the hour, and I really appreciate your time. Have a good one, everybody. Thank you.
Thank you, guys. Thanks for inviting me. Cool, Jen.